this is the GVC Algebra review. If you haven't scored well on the GVC Algebra quiz or haven't taken it yet, this review could be handy in helping you prepare and get ready for it. So we start by simplifying binomials. What you want to do is take this first term and multiply it by both of the terms in the second polynomial. So we'll take x times x, and that's x to the second power, and then x times 5, that's 5x. Okay, then we're also going to multiply this 3 by each of the terms over there. Right, so we'll take 3 times x and get 3x, and 3 times 5, that's 15. Finally, you want to combine like terms. So 5x plus 3x becomes 8x. So your final answer will look like x squared plus 8x plus 15. Okay, this is some practice just to get us ready before we do factoring. So we're kind of working in one direction and then we'll go the other. So again, we're going to take this x times each of the things over here. And sometimes I draw myself a little mark just to remind myself that I'm multiplying by each of those terms. And then I'm multiplying negative 4 by each of those. So it's going to be negative 4x minus 28. Okay, these two are like terms. They both have the same exponent raised to the same power. So I can add their coefficients. I can add 7 and negative 4, and I'll get 3x out of that. And x squared didn't have a like term, so I'll just stick that out front. Negative 28 didn't have a like term, so that will go at the back. Last one, number 3, we've got x times x and times negative 2. So x times x is x to the second power and negative 2x. Then we'll take negative 8 and multiply by each of those, negative 8x plus 16. These are like terms, so I'll add their coefficients and keep the variable. That's how those go. Okay, now what we're going to do is factor. So essentially we're working backwards. Now, because we are using these patterns, I want you to take a look up here and notice that this number 8 is 5 plus 3. And also this number 15 is 5 times 3. Over here we have 3. 7 minus 4 is 3. And 7 times negative 4 is negative 28. Negative 2 plus negative 8 is negative 10. And negative 2 times negative 8 is positive 16. Okay, so we can see how these patterns sort of work. What we're going to do now essentially is go backwards. So we're looking for two numbers that multiply to give 20. But when we add those same two numbers, we get 9. So I showed the class this thing I'm calling the X method. Up top, I'm putting A times C. And A, there's nothing written there, so it's really just 1. So I'm taking 1 times 20. That's what goes up at the top. And we're using that to say we need two numbers that multiply to give 20. So it could be 1 times 20, 2 times 10, 4 times 5. It could also be negative 1 times negative 20, negative 2 times negative 10, negative 4 times negative 5. Okay, these are all options with integers, so not dealing with any fractions or decimals or anything like that, just integers. We can multiply these things to get 20. Now I also want to find two numbers that I can add up to give me 9. Okay, so we want the numbers to multiply to 20, but also add up to 9. So I've listed all the factors over here. If I add these two numbers together, you get all those choices. This is the one that fits, right? 4 times 5 is 20, and 4 plus 5 is 9. So the two numbers that I'm going to use are 4 and 5. And then to keep the method going, we would divide by a, this number in front of the x squared, or the coefficient of the quadratic term. But dividing by 1 doesn't really change anything, so I'm just going to leave it like that. Looks a little bit simpler. And we'll list the factors. So they are 4 and 5, so it will be x plus 4 times x plus 5. Now I want to show you that if we did the same exercise as what we did on 1 through 3, if I took x times x and times 5, I'd get x squared plus 5x. And then if I took 4 times x and times 5, I'd get 4x plus 20. And when I combine like terms, I'd get right back to where we were, right? So by showing this work at its next step, I know that this equals this, which equals this. So our goal in this one is to take it from the trinomial form. I've got so many colors on here. We're going from this form to factored. Okay, that's the goal of this part. All right, let's try another one. Over here, I need two numbers that multiply to negative 44, but when I add those numbers, I get negative 7. And as you become better at this, you'll just be able to think of those numbers sometimes. They'll just come to mind. But in the meantime, I know that one of the numbers needs to be negative, so that when I multiply them together, I get negative. And the bigger one needs to be negative, so that when I add them, I get a negative answer. If I divide by 3, I'll get fraction or decimal answer. So it looks like 4 and 11 might be it. 4 times negative 11 is negative 44. And 4 plus negative 11 is negative 7. So we've got our two numbers. So I can list my factors as x plus 4 and x minus 11. That's how you factor. Let's try another. Two numbers whose product is 32, but their sum is negative 12. Okay, so two things I can multiply together to get 32. 4 times 8, 5, 6, 7, 8, that's it. I could also do negative for each of them. Okay, so there's all the factors. Now I'm going to look at adding these numbers together. If I add them here, I'd get 33, 18, 12, negative 33, negative 18, negative 12. That's the one we want, right? Because we've got negative 12 there. So our two numbers are negative 4 and negative 8. So our factors look like x minus 4, x minus 8. Okay. Now here we're going to take what we just did, but then go one step further. So a times c, the coefficient there times the constant, that's 18. And then the number we need to add up to, 11, goes right there. Can you think of the two numbers that would make this work? They're 2 and 9. So I'm going to list the factors x plus 2 and x plus 9 equals 0. Because I'm now in an equation, I want to solve to find out what x is and what x is. So I know that if I take some number, like 50, and multiply by 0, I'm going to get 0. If I take 1,000,000 times 300,000 times 450 trillion times 0, I will get 0. So in order to make this equation true, I need for this to equal 0. So I'm thinking to myself, what value could I plug in for x that would make x plus 2 equal 0? And it's negative 2. Negative 2 plus 2 equals 0. If I plugged that in there, I'd get 0 for that. Negative 2 plus 9, that's 7. But 0 times 7 is still 0. So negative 2 is one answer that will make this equation true. Let's see if there are any others. Oops. If I were to replace this x with something so that x plus 9 equals 0, what would that x be? It would be negative 9, right? Negative 9 plus 9 would equal 0. Negative 9 plus 2 would equal negative 7, but negative 7 times 0 is still 0. So it doesn't matter that that one didn't go to 0. As long as one of them does, then our answer goes to 0. Okay, so it's just one step farther from what we were doing before. So we're going to factor this. the coefficient of the quadratic term times the constant, that's negative 40, over the coefficient of the linear term, negative 3. We want two numbers that we can multiply to get negative 40 and add to get negative 3. Yeah, these are the two numbers, right? I recommend, if you're not figuring them out on your own yet, to just go ahead and pause once you get the x started so that you can see what they would be. Okay, so let's ask ourselves, what value for x would make x minus 8 equals 0? Was it 8? 8 minus 8 equals 0. What value for x would make x plus 5 equal 0? It would be negative 5, right? So those are our two solutions. That's part of why factoring is so powerful, is because it helps us find these answers. If I were to plug negative 5 in for every x up here, I would get the answer 0. If I were to plug in 8 for every x up there, I would get the answer 0. Let's try it with one of them just so that we can see that. 8 squared is 64. Negative 3 times 8 is negative 24. Minus 40, does this equal 0? Well, 64 minus 24 is 40. And 40 minus 40 is 0. So yes, that works. And if I plugged in negative 5, I would get the same thing. Let's try this one. A times C, 1 times 54 is 54. B is negative 15. Go ahead and pause the video here and see if you can think of those two numbers. Because we're in an equation, we want to think of what would make each of those equal 0. And 6 would work, and 9 would work. Those are our two answers. Okay, sometimes the equation will not be written in standard form for us. So in this case, I want you to start by adding 4x to the linear term, right? We're adding like terms. So we get x squared plus 14x plus 33 equals 0. Okay, so now we're going to take 1 times 33 and our b value 14. What are two numbers that we can multiply together to get 14? Let's see, that's not coming to mind, so I gotta start my list. 3 and 11. 3 plus 11 is 14. Don't know why I couldn't think of that. X plus 3, x plus 11. So our two solutions are negative 3 and negative 11. Add 3x to both sides. We get x squared minus 8x minus 20. I think negative 10 and 2. So our solutions are 10 and negative 2. This time I'm going to add 21 to the constant. It doesn't have an x by it, right? So we've got x squared minus 14x plus 24. Okay, that is how we do the factoring problem. So will you turn to the third page? Let's go ahead and I want you to try problem 46. So go ahead and pause the video right here. I want you to try problem 46 all by yourself. All right, if you've tried it, then you can turn this back on, and this is what we're looking at. So my two solutions would be negative 3 and 1. Is that what you got? If that's not what you got, can you see the error that you made? Okay. All right, let's head back, and now we'll talk about the second section. This is square root. So first off, we want to identify what the square root is. Square root is the inverse operation for something raised to the second power. Okay, so if I found that 1 to the second power is 1, then I know that the square root of 1 is 1. That's not a great example. 2 squared is 4. The square root of 4 is just 2. 3 squared is 9. Square root of 9 is 3. So essentially what I'm looking for is what number multiplied by itself is the 9 or the 4 or the 1. So can you think of what number times itself equals 25? And that number is 5. 5 times 5 is 25. Now, the square root of 8 is a little bit trickier. I know that if I prime factor 8, it divides into 4 and 2 divides into 2 and 2. I know that 2 times 2 would be 4, but look, there's another one left over. So if I were simplifying this, I could bring this pair of 2's out front. Square root of 4 is 2, but then we have this 2 left over that cannot be simplified. So we get an irrational answer here, 2 root 2. If I divide 14 into 7 and 2, it's 2 prime numbers. Neither of them is a pair of anything, so it stays at root 14. That's our simplified answer. Nothing can be removed there. What if we have a negative radical, right? So this, by definition, the square root of negative 1 is I. So each time you have a negative under here, we're thinking about dividing away negative 1. So we've got negative 1 times 4. And we're going to take that negative 1 outside of the radical and put an I there in its place. I instead. So we're looking at I root 4. And the square root of 4 is 2, because 2 times 2 is 4. So this becomes 2I. On 17, if I divide down 17, well, we've got a negative 1 in there too. 9 divides into 3 and 3, so I can take out this pair of numbers. The negative 1 becomes an I outside of it. That takes care of that. But look, we have 1 3 left over all by itself. That has to stay behind. We've got negative 1 times 6. 6 is 2 times 3. No pairs of anything. But we do want to simplify by pulling that negative, replacing the negative 1 with an I out in front of the radical. Okay. So now we're going to solve an equation by taking the square root. We know that x to the second equals 49, but we want to know what just plain x is. So an inverse operation for squaring something is to take the square root. X times x equals x squared, so that's the square root there. 7 times 7 equals 49, so that's the square root there. But there's another answer. 7 times 7 does equal 49, but also negative 7 times negative 7 equals 49. So we have two answers. So what I want you to do is when you take the square root and you're solving, I want you to get in the habit of putting this symbol out front, that our solution could be positive 7 or negative 7. Could go either way. So x squared equals negative 20 was just plain x. X equals plus or minus, so let's see, let's break down negative 20. We have negative 1, so we're going to have an I. And then 20 divides into 4 times 5. 4 is 2 times 2, so we have a pair of things and one left over. So we're going to have 2I root 5. Conventionally in mathematics, we put number before a letter. I2 is also correct, it's just not how it's conventionally done. Okay, square root both sides, and we get x equals plus or minus negative 1 times 10, so that we'll have an I. 10 is 2 times 5, no pairs of anything to be removed, so it's going to be plus or minus I root 10. Okay, sometimes we have to do a little work to isolate the x squared. So in this case, we know that 2x squared is 72, but before I square root both sides, I need to get rid of anything except x squared. So I'm going to divide both sides by 2. That leaves me with 1x squared equals 36. Now I can take the square root of both sides, and I find that x equals plus or minus 6. Divide both sides by negative 5. Let's see, 80 divided by 5, that's 36. Is it going to be negative 16? Take the square root of both sides, and we get x equals plus or minus, let's see, 4 times 4 is 16, but we also have a negative, so it's going to be plus or minus 4i. Divide both sides by 7. We get x squared equals negative 11. Square root both sides, and we find that x is plus or minus I. Let's see, 11 is prime already, so I root 11. Okay, on 25, a little bit more work. To isolate x squared, I'm going to start by subtracting the constant. I want to save division for the very last step in isolating. So x squared equals 4. As we take the square root of both sides, we get plus or minus 2. And we can check it to make sure it's right. If I replace this x with 2, I would get 2 squared, which is 4. 4 times 4 is 16, plus 3 is 19. Let's check with negative 2. Negative 2 squared is also 4. 4 times 4 is 16, plus 3 is 19. Both cases work. So I'm happy with that answer. Okay, we'll start by adding 5. Negative 2x squared equals 24. Divide by negative 2. X squared equals negative 12. Now that x squared is isolated, I can square root both sides. Let's see. We've got negative 1 times 12. 12 is 4 times 3. 4 is 2 times 2, so 2i root 3. Subtract 5. I with 1, 2 left behind. Okay, that's the end of the square root portion. So head over to problem 47. I want you to try this independently. Go ahead and pause the video here. When you're done, turn it back on and you can check your work. You want to start by subtracting 8. If I did start by dividing 2, I can show you how to do that as well in a second. Square root. Let's see, 56 divided by 8, and 8 times 7 is 56, 4, 2, 2. Okay, so we have a pair, plus or minus 2, and the 7 and 2 are not a pair, so it's going to be root 14. If you started by dividing by 2, you just need to make sure you divide every single term by 2. And then keep going from there, and you should still get the same answer that we got. Okay, completing the square. Solve. What we're going to do here is, since we have quantity squared, we're going to use that square root method that we've just been practicing. So we'll take the square root of both sides, and this symbol and that second power cancel each other out, so we have just x plus 4 equals plus or minus, let's simplify this radical. Let's see, 30 divides into, we could say 6 and 5, 2 and 3. No pairs of anything, 2, 3, and 5, so it stays at 30. So we know that x plus 4 equals plus or minus the square root of 30. Finally, we want to subtract 4 from both sides. So we will get x equals negative 4 plus or minus the square root of 30. Okay, here we're going to square root both sides. X minus 7 equals plus or minus, let's see, 32 divides into 16 and 2, and the square root of 16 is 4, so we're going to have 4 root 2. I could have kept dividing down, right? Then we'd have a pair of 2's and another pair of 2's, so we still would have had a 4 out front. Okay, we want x alone, so the last step is going to be to add 7. So x equals 7 plus or minus 4 root 2. Oh, and one more. Okay, square root. Get x plus 7 equals plus or minus, let's see, that's going to be 25 times 2, so we're going to get 5i root 2. Subtract 7 from both sides. We have x is negative 7 plus or minus 5i root 2. Okay, expand. Let's see. If I multiply this out, x plus 5 times x plus 5, this is like what we did on the first 3 problems. We're going to take x times each of the terms in the other binomial, x squared plus 5x, then take 5 times each of the terms over there, so we have 5x plus 25, combine like terms, x squared plus 10x plus 25. Notice that 10 is 5 times 2, and 25 is 5 squared, 5 times 5. Whoops, I did not mean to do that. Okay, heading over here, let's expand x minus 7. Okay, negative 14 is negative 7 times 2. 49 is negative 7 times negative 7. Without solving this next one, what do you think the answer will end up being without actually multiplying it out based on the pattern that we've got on these last couple? Will you write down your prediction? Then we'll see if it really worked. X plus 1 times x plus 1. Did you guess x squared plus 2x plus 1? Because the 2 is our number 1 times 2, and then 1 is 1 times 1, 1 squared. Okay. Here, we want to find the value that completes the square and then rewrite as a perfect square. Okay, so just like what we were doing before, what we want to do here is get a factor that looks like x with something squared so that we can take the square root of both sides. Okay, so the factor I would want here would look like, let's see, I'll write it out like this. X times x would give me x squared. And then since it's in this format, whatever I write next has to be the exact same in both places. So do I want it to be positive or negative something? I want to be negative so that when I subtract them, I get negative 10. And if they have to be an exact match of each other, it's got to be 5 and 5, right? Negative 5 plus negative 5 is negative 10. So I want my factor to look like x minus 5 squared. But if I keep multiplying this out, I'll get x squared, minus 10x plus 25. So in order to go from here to here, I actually need to add something into that spot. Can you see what it is I need to add? It's the 25, right? That's going to make this and this be equal to each other, which will make it equal to that. And that. Looking a little bit messy. So essentially, what we're doing is saying, take this linear value, divide it by 2, and that's what's going to go here. Then square that number, so multiply it by itself, that's what's going to go there. Okay, so on this one, the factor is going to look like x minus something squared. And that something has to be a match to itself so that when I add them, I get negative 8. So I'm thinking negative 8 divided by 2, which is negative 4. And to find the value that goes in this place, I need to square that. So I'm thinking negative 4 times negative 4, it's going to be 16. I want you to pause before you do number 3. See if you can do this independently, and then turn the video back on and check. The factor that I'm going to build has half of that. So it's going to be x minus 10. And the number that goes in this spot is negative 10 times negative 10, which is 100. Okay, now we're ready to complete the square. So what we're going to do to solve these is we're going to move the constant to the other side of the equation. That way I can work on building that perfect square that we were thinking of. X plus half of 12 is 6, but the number that goes here is 6 squared. If I add it on this side of the equation, I also need to add it on that side of the equation. That's the only way that it's still true. 5 plus 36 is 41. Now I have quantity squared equals number. So at this point, I can take the square root of both sides. Then I'll have x plus 6 equals plus or minus 41. And I think the square root of 41 just stays there. Yeah, there's nothing we can divide out of it. And then I'll subtract 6 from both sides. We get x equals negative 6 plus or minus the square root of 41. It's a lot. Let's try the next one. Maybe what you could do is pause, and then if you're not sure what to do, you could watch a step and pause before the next step is completed, right? Just so that you're thinking about it each time, and then if you get on the wrong track, you can see some guidance in how to get back. I'm going to add half of that 6, so 3, and then I'm going to put a 9 here and a 9 over there. That's the only way to keep the equation true. If I add something to one side, I have to add it to both. Square root both sides. The square root of 1 is 1. This one's unique. Because there are no radicals. So I'd want you to continue to simplify. I want you to look at what is negative 3 plus 1 and negative 3 minus 1. Negative 3 plus 1 is negative 2. Negative 3 minus 1 is negative 4. So our two answers in this case are negative 2 and negative 4. Half of negative 8. Square it and add that to both sides. Take the square root. (14) is just 2 and 7. There's no pair of things I can remove. Okay, I think that's it for the completing the square type problem. So hop to number 48. Pause the video and see if you can solve this one by yourself. All right, how'd you do? We have one last type of problem to look at. These are solved using quadratic formula. So first they want us to identify A, B, and C. We want to put the equation in standard form to do that. I don't know why I'm writing all this. So we're going to start by subtracting 3 from both sides. Since there's no like term with the 3, it's going to be a third term on here. Now I know that A, that's the coefficient of the quadratic term, is 4. B, the coefficient of the linear term, is 8. And C is our constant, negative 3. That's all we need to do on this part. We'll add 5. Okay, so A is -2. B is 1. Whoops, I wanted to make that smaller. Let's see if I can do that. Sorry. Okay. And C is 5. All right, now they want us to find the discriminant. So we're going to complete all the steps that we did up above. Then we're also going to use the formula to find the discriminant. And the discriminant comes from b squared minus 4ac. So I'm going to take b squared, that's 7 squared, minus 4 times a is -12, times c is 5. So 7 squared is 49. I recommend using the calculator here. It's really easy to make errors. -12 times 5 is 60. -60. And -60 times -4 is 240. So I think we get 289 out of this one. I'm going to check on my calculator real quick. I would hate to have an error sitting on here, so let me just verify. Yeah, 289. So we want b squared minus 4 times a times c. That's going to be 16, 60 and 18, that's 78 times 4. I'm just going to go ahead and stick it in my calculator since I'm going to check there in a second anyway. Minus 4 times 6 times -13. I got 328. So that part must have been 312. Okay. This one I can do in my head. 4, and then positive 32 times -1, so -32. This is going to be -28. Okay, finally solve using the quadratic formula. Okay, we're going to keep doing all the steps that we've done, and then add on just a little bit more. A is 1, B is 5, C is -9. Quadratic formula, remember, is x equals -b plus or minus the square root of the discriminant, b squared minus 4ac, all over, so a really long fraction line, 2 times a. So let's do this. X equals -b plus or minus the square root of b squared minus 4 times a times c, all over 2a. I'm going to start by finding the discriminant. So that's 25 plus 36. It's going to be 61. So we have -5 plus or minus the square root of 61 all over 2. I can check to see if square root of 61 simplifies, and it doesn't. So there's our answers. We have two answers, -5 plus the square root of 61 over 2, and -5 minus the square root of 61 over 2. Start by adding 7. Identify A, B, and C. out the formula. Sorry. B squared minus 4 times A times C all over 2A. That's 100 minus 28 times 7, negative 96. 10 plus or minus the square root of negative 96 over 14. Square root of 96 is 4 root 6, so we get 10 plus or minus 4I root 6 all over 14. We're going to look at these three numbers to see if there's anything we can divide away from all three of them. There is. We could divide away a 2. So if I do that, I will get 5 plus or minus 2I root 6 all over 7. And that's my final answer. Okay, subtract 6. We'll get 4x squared minus 11x minus 6 equals 0. Identify A, B, and C. Put it in the formula. And that's the end. All right, try out number 49. Go ahead and pause here while you work it out. Then you can turn the video back on to check your work. How'd you do? Okay, the quiz is going to look exactly like what you've got in these 4 boxes. So take a second and try out these 2 practice quizzes, and then contact me, and I know that you'll be ready to move on with the next part. Let's see. I'll just solve this and you can check your work. Okay. So add line x squared plus 5x plus 6. I need 2 numbers whose product is 6, adds to 5. That's going to be 3 and 2. So we have x is negative 3 and negative 2. Square root, add 7 to both sides. 3x squared equals 36. Divide by 3. X squared is 12. Square root. X is plus or minus 2 root 3. When we're completing the square, we want to move the constant over. Half of 8 is 4. 4 squared is 16. Negative 75 plus 16, negative 59. And quadratic formula. Let me know when you're ready for the test after completing this review.